Dear student, now I will discuss about a new chapter, that is your group 18 elements. Group 18 elements are called zero gas elements because the valency of group 18 element is your zero. Group 18 elements are also called noble gas element because group 18 elements have stable electronic configuration. They are more stable as compared to the other element in the modern periodic table. Group 18 elements are also called erogens because these elements are found in air. Group 18 elements are also called rare gas because these elements are found in the atmosphere in traces amount. Group 18 elements also called inert gas because they are chemically inert. These are the different names of group 18 elements. The group 18 elements are helium, neon, argon, krypton, xenon, radon. These are the elements which are present in the group 18 in the modern periodic table. Next I will explain about the occurrence of group 18 elements. All the elements generally found in the atmosphere in free state except radon. All the elements of group 18s are generally found in monoatomic state in the atmosphere. The total abundance of group 18 elements in dry air is 1%. Helium and sometimes neon are generally found in mineral radioactive origin like pitch blende, monazite, cleveite. The main source of helium is natural gas. Radons occur in the radioactive decay product of radium. These are the occurrence of group 18 element. Next I will explain about the position of group 18 elements in the periodic table. All the group 18 elements are monoatomic gases. The group 18 elements do not have any tendency to gain electron or lose electron. That's why the valency of group 18 element is your zero. Since it have zero tendency to lose electron, that means the group 18 elements have high ionization energy. On the other hand, the group 18 elements do not have any tendency to gain electron. That's why the group 18 elements have zero electron affinity. In the Mendeleev periodic table, there are 8 groups are present, but in this group there is no placement of the group 18 element. After successive modification of the periodic table and studying the properties of the noble gas, it is finally clear that the noble gas elements present in the 18 group of the modern periodic table, which is after group 17 and before group 1. Next I will explain about the general trends in properties. At first I will discuss about the general trends in physical properties. At first I will discuss about the electronic configuration. The general outermost electronic configuration of group 18 element is NH2 NP6. The atomic number of helium is your 2. The electronic configuration is your 1s2. Next is your neon having atomic number 10. Electronic configuration is your helium 2, 2s2, 2p6. Next is your argon having atomic number 18. Electronic configuration is your neon 10, 3s2, 3p6. Next is your krypton 36. Electronic configuration is your argon 18, 3d10, 4s2, 4p6. Next is your xenon having atomic number 54 and the electronic configuration is your krypton 36, 4d10, 5s2, 5p6. Next is your radon having atomic number 86. Electronic configuration is your xenon 54, 4f14, 5d10, 6s2, 6p6. Look at that. Here 2s2, 2p6, here 3s2, 3p6, here 4s2, 4p6, here 5s2, 5p6, here 6s2, 6p6. From this it is clear that the general outermost electronic configuration of group 18 element is NH2NP6. Next physical property is your atomic radii. The atomic radii of inert gas element is high. The atomic radii of the inert gas elements goes on increases from top to bottom due to increase of the cell. That means due to addition of new cell. If you will think about the helium, then helium belongs to K cell. If you think about neon, then neon belongs to K cell and also with L cell. If you think about argon, then argon belongs to K cell, L cell, M cell, like that. Look at that, there is increasing in the number of cell from helium to neon, neon to argon. So there is an increase in the atomic radii from helium to neon, neon to argon, argon to krypton, krypton to xenon, xenon to radon. Next physical property is your ionization energy. The ionization energy of group 18 element are higher than as compared to the other element present in the modern periodic table. This is due to the small atomic radii of group 18 element. The ionization energy of group 18 element goes on decreases from top to bottom. So I can write helium having more ionization energy than neon, which is more ionization energy than argon. The ionization energy of argon is greater than krypton. The ionization energy of krypton greater than xenon. The ionization energy of xenon is greater than radon. This decrease of ionization energy is due to the increase in the atomic radii from top to bottom. Next physical property is your electron affinity. The electron affinity of group 18 element is 0 or having positive electron gain enthalpy. Since the group 18 element do not have any tendency to gain an electron, so the group 18 element having 0 electron affinity. Next physical property is your melting point and boiling point. The melting point and boiling point of group 18 element is very low. This is due to the weak van der Waals force of attraction. However, the melting and boiling point goes on decreases from top to bottom. Next physical property is your solubility. The solubility of group 18 element is very less. However, the solubility increases from top to bottom of group 18 element. Next property is your ease of liquefaction. Group 18 element are not easily liquefied. This is also due to weak van der Waals force of attraction. Next property is your state of existence. All the group 18 element exhibit in monoatomic state. Next physical property is your characteristics spectra. Every group 18 element shows a particular characteristics spectra by which they can easily identify. This is all about the physical property of group 18 element. Next I will explain about the trends in chemical properties. All the group 18 elements have less tendency to react with another. That means noble gas shows extremely slow reactivity, but the reactivity increases from top to bottom. That means helium is less reactive than neon, which is less reactive than argon. Argon is less reactive than krypton. Krypton is less reactive than xenon. Xenon is less reactive than radon. Look at that, the reactivity of radon is more than xenon. So radon can easily form bond with another atom to form a compound. But remember, due to high reactivity and short half-life period of radon, the compounds of radon are highly unstable. Only a few fluorides and oxides of radon are formed. Xenon can exist in +2, +4, +6 and plus 8 oxidation state, which bonded to highly electronegative atoms such as fluorine and oxygen to form different types of compound. The compounds of xenon are HCF2, HCF4, HCF6, HCOF4, etc. Look at that, krypton is less reactive than xenon, but krypton form various types of compound in which krypton shows +2 oxidation state. That means krypton forms compounds with the +2 oxidation state. These are the chemical property of group 18 element. Next I will discuss some compounds of xenon. First is your xenon difluoride having formula HCF2. Xenon difluoride can be prepared in different way. When xenon is treated with the fluorine in a nickel tube at 673 Kelvin, then xenon difluoride is formed. Here xenon and fluorine are taken in 1:3 ratio by volume. Second method is when xenon is treated with fluorine in presence of mercury vapor, then xenon difluoride is formed. Next method is xenon when treated with O2F2, then xenon difluoride plus oxygen is formed. This reaction is carried out at 155 Kelvin. Xenon difluoride are colorless crystalline solid. It is less volatile than other fluorides of xenon. Xenon difluoride dissolved in HF without reacting. When xenon difluoride is treated with hydrogen, then it gives xenon plus HF. When xenon difluoride treated with water, then it gives xenon and HF and also oxygen. When xenon difluoride treated with I2 in the presence of BF3, then xenon and IF is formed. When xenon difluoride is treated with sulfur trioxide, then xenon and peroxysulfuryl difluoride is formed. When xenon difluoride is treated with HCl, then xenon and HF and chlorine is formed. When xenon difluoride treated with PF5, then a complex compound is formed. This is your complex compound. These are the chemical reaction of xenon difluoride. Xenon difluoride is used as an fluorinating agent. Xenon difluoride is also used as an oxidizing agent. Xenon difluoride also used for the preparation of xenon. The geometry of xenon difluoride is trigonal bipyramidal shape or structure of xenon difluoride is your linear. This is the structure of trigonal bipyramidal of xenon. In the center, xenon is present. These are the hybrid orbitals. Here fluorine atom is present. Here also fluorine atom is present. Look at that. This look like a trigonal bipyramidal. The hybridization of xenon in XCF2 is sp3 dehybridization. Next compound of xenon is xenon tetrafluoride. Xenon tetrafluoride can be prepared by passing electrical discharge through mixture of xenon and fluorine at 193 Kelvin temperature and pressure 2 to 15 atm. Here I can write electrical discharge. Xenon tetrafluoride can be also prepared by taking a reaction between xenon and fluorine at 673 Kelvin and at 6 atm pressure in a nickel tube. This is the reaction. Here xenon and fluorine are taken at 1:10 ratio by volume. Xenon tetrafluoride is colorless, crystalline, solid. Xenon tetrafluoride is quite stable in pure and dry state. Xenon tetrafluoride can dissolve in HF without any reaction. Xenon tetrafluoride when react with the hydrogen, then it gives xenon and HF. When xenon tetrafluoride react with the water, then xenon and HF and XiO3 and fluorine is formed. When xenon tetrafluoride react with the Ki, then xenon and I2 and Kf is formed. Similarly, when xenon tetrafluoride react with the SF4, then xenon and SF6 are formed. Similarly, when xenon tetrafluoride react with the SbF5, then a complex compound is formed. This is your complex compound. These are the chemical reaction of xenon tetrafluoride. Xenon tetrafluoride can be used as an fluorinating agent. It is also used for the preparation of xenon. The geometry of xenon tetrafluoride is your octahedral, and the shape or structure of xenon tetrafluoride is square planar. The hybridization of xenon in XCF4 is sp3d2 hybridization. In octahedral geometry of xenon tetrafluoride, xenon is present at the center, fluorine atoms are present like this, and there are two lone pair present like this. This is your octahedral geometry of xenon tetrafluoride. The shape of xenon tetrafluoride is your square planar. Next compound of xenon is your xenon hexafluoride. When xenon is treated with the fluorine at 523 Kelvin to 573 Kelvin and at pressure 50 atm in nickel vessel, then xenon hexafluoride is formed. When xenon tetrafluoride react with the O2F2 at 143 Kelvin, then xenon hexafluoride is formed. along with the O2 byproduct is formed. Xenon hexafluoride is a colorless crystalline solid, but its vapor have greenish yellow. Xenon hexafluoride dissolve with HF and form a solution which is a good conductor of electricity. Xenon hexafluoride when react with hydrogen, then xenon and HF is formed. Xenon hexafluoride when treated with water, then HCOF4 and HF is formed. This reaction is only possible upon partial hydrolysis. When xenon hexafluoride undergoes completely hydrolysis, then xenon trioxide is formed. Also, HF byproduct is formed. Xenon hexafluoride when treated with silicon dioxide, an explosive reaction will be possible. At first, xenon hexafluoride when treated with SiO2, then HCF4 and SiF4 is formed. Again, HCF4 plus SiO2 gives HCO2F2 plus SiF4. Again, HCO2F2 plus SiO2 gives HCO3 plus SiF4. HCO3 an explosive substance. So this reaction is an explosive reaction. We know that glass contains SiO2. So remember, HCF4 cannot be stored in the glass due to these reactions. When HCF4 is kept in a glass container, then an explosive reaction will be possible. That's why the container will be blast. Due to this, HCF6 cannot be stored in glass container. When HCF6 react with the MF, then a complex compound is formed like this. Here M equal to sodium, potassium, rubidium, cesium. When HCF6 react with the HF, then HF2 minus and HCF5 plus are formed. These are the chemical reactions of HCF6. HCF6 is used as an fluorinating agent and also an oxidizing agent. The geometry of HCF6 is pentagonal, bipyramidal. The shape or structure of HCF6 is distorted octahedral. This is your distorted octahedral. Here a lone pair is present. The hybridization of xenon in xenon hexafluoride is sp3d3. The other compounds of xenon is your xenon trioxide. It is an colorless explosive substance. HCO3 is a powerful oxidizing agent. It is used as an explosive substance. The hybridization of Hc in HCO3 is your sp3 hybridization. Geometry is your tetrahedral. Shape or structure is your trigonal, pyramidal. This is your tetrahedral geometry. This is your lone pair. This is your tetrahedral geometry. Next compound of xenon is your XeO2F2. The hybridization of xenon in XeO2F2 is sp3 dehybridization. Geometry of XeO2F2 is trigonal, bipyramidal. Shape of XeO2F2 is seesaw structure. Hybridization of xenon in XeO2F2 is your sp3d. Geometry is your trigonal, bipyramidal. Shape or structure is your seesaw structure. This is the seesaw structure of XeO2F2. Here a lone pair is present. Next compound of xenon is your XeOF4. The hybridization of xenon in XeOF4 is sp3d2 hybridization. The geometry of XeOF4 is octahedral. The shape or structure of XeOF4 is square pyramidal. This is the octahedral geometry of XeOF4. This is your lone pair. Next I will discuss about the uses of inert gases. First is your uses of helium. It is used in inflating the aeroplane tire. Second is your used in filling ships and weather balloon. Mixture of helium and oxygen in 1:4 ratio by volume is used for respiration by asthma patient and sea divers. It is used as an pressurizing agent in rocket to expel the liquid oxygen and liquid hydrogen. It is used as a cryogenic liquid to produce low temperature for research work. Next use is it is used in gas thermometer to measure low temperature. Next use is it is used to prevent oxidation of precious ornament during welding. These are the uses of helium. Next is uses of neon. Neon is used in beacon light, which is used in aeroplane, ships, telephone tower, and lighthouse, because orange red beacon light can penetrate the mist and fog. Neon is also used in formation of red, orange, green or blue light. These are the uses of neon. Next is uses of argon. Argon is used in radio valve. Mixture of argon and nitrogen is used in electrical bulb to increase the efficiency of the filament. Argon is also used to produce green colored light. Argon is also used to produce inert atmosphere for welding and extraction of easily oxidizable metal. These are the uses of argon. Next is uses of krypton and xenon. Both krypton and xenon are used in discharge tube and electrical bulb. Next is uses of radon. Radon is used in radiotherapy. It is also used in research work. It is also used for detecting defect in casting of steel. These are the uses of radon. This is all about the group 18 element.